In this video, we're going to focus on two things. Number one, what makes something a prism? And then number two, how to find the volume of a cylinder. Okay, so a prism is just some three-dimensional shape, a polyhedron, with two congruent parallel bases at the ends of the solid. So that's a little bit wordy, but basically what this means is that there's a two-dimensional shape, like for example, we have this triangle here. And then that triangle, this two-dimensional shape, is at the top and the bottom of our 3D shape. And you can kind of think of like this triangle just from each of its vertices. Okay, so from each of its vertices, it just extends up and connects with another triangle. Okay, so these triangles here and here for a prism, we would call these the bases. So this is the base, and this is also the base of our prism. Similarly, we can pick any shape that we want for the base. It doesn't have to be a triangle. This is just a triangular prism. But we could pick a square for the base. So we could, and this shape actually doesn't look like a square, but it looks more like a rectangle. But you could pick a square to be your base for your top and the bottom of the shape, a pentagon, a hexagon with 6 sides, a rectangle, or we'll look at something where we have an oblique prism, where it's basically just a prism, but it's the bases aren't right on top of each other. We see that we have one base that's located here, the other base is a little off to the left, and so when they connect up, it tilts this prism a little bit to make it oblique. Okay. Sorry about this watermark right here. I'll have this out of the shot when I'm doing problems, but just ignore this when we're doing things. So that's what makes something a prism. You just have some 2D shape connected as the base for the top and the bottom. And we are specifically going to focus on a type of prism called a cylinder. Okay. So a cylinder is a prism because it has a circle for its base at the top and at the bottom. So if we think about the volume for a cylinder or for any prism, in fact, we're going to get this formula. So the formula is that the volume, okay, the space that it takes to fill this up, how much water could this tank fill up with, the amount of water, that's the volume, the space that it takes up. That's going to be equal to the base. We just talked about the base a second ago. It's going to be equal to the base. And when we talk about this B here that represents the base, more specifically, this is talking about the area of the base, and that'll be multiplied by the height. How high does our prism go up? Is it pretty short? Does it stretch up pretty high? And if we multiply those two things together, we can figure out how much space is taken up inside of our prism. So specifically for a cylinder. Couple things we need to know right now. We're going to go over some basic formulas that we'll be using throughout the rest of this time, the rest of these lessons. So number one, what is the area of a rectangle or square? What's the formula for that? Okay, so to find the area of a rectangle or square, that would be the length times the width, okay, of your rectangle or square. We can think of length here and width here. They could be the other way around, and we just multiply those two numbers together, however long our rectangle or square is and how wide is it. For a triangle, we can think of a triangle as a rectangle or square, but just cut in half, because that makes a triangle. So if we just took this formula and cut it in half, we just multiplied this by 1/2, then we get the area of our triangle, okay? And then for a circle, the area of a circle, as we talked about in the last unit, is going to be pi. So we do pi, multiply that by the radius, and the radius is squared, okay? So there are formulas that we're going to be using. And remember just a second ago how I said the B here represents the area of the base. So for cylinders, since all their bases are circles, the B here is going to be the area of the base, the area of the circle, the area of the circle right there. So the B we'll put in place for that is pi r squared, because I know the base is a circle. I want the area of these circles, so that's pi r squared. Then we'll just bring down the height, so I have pi multiplied by r squared multiplied by the height. And this is the formula we're going to use to find the volume of cylinders. So here's what we will do. Pretty straightforward. We just have to plug in the values that we see in for our radius and our height, multiply those, and then we end up getting the volume. So the volume for this fish tank is going to be equal to, and I'm going to change pi to 3.14. So 3.14 times the radius, there's the radius, 6, make sure that's squared, so 6 squared, and then multiplied by the height. And this thing has a height of 15 inches. So I just simply take all of those numbers and multiply them together, and I get 1,695.6. Okay. Now, what I care about, and it might already be in the Canvas assignments when you do this, but we have to make sure that we have the right units here. So since this is in inches, this would be inches. And whenever we talk about volume, volume has 3 dimensions. Any 3-dimensional thing, right? It has a height, it has length, and width. So this is going to be inches cubed to represent those 3 dimensions, okay? So 1,695.6 inches cubed. That is my answer. Okay, let's try this with another one. So volume is going to be equal to 3.14 times 8 squared times 6 times 8. That was our radius. I just plugged it in for the radius there. 6 was the height. So 3.14 times 64 times 6 gives me 1,205 point. Let's go ahead and round to the nearest tenth, so 0.8. And again, inches cubed. So essentially, if we were to fill both of these up with water, it looks like this fish tank could hold more water than this squat little cylinder, okay? So it has a greater volume, it can hold more water inside of it. And then the last one we'll do, so the volume is going to be equal to 3.14 multiplied by the radius. Oops, okay, check this out. We have to be a little more careful this time when we look at the picture. So the 7 here is talking about the distance from here to here. This whole line is 7. This is not the radius. Remember, we want the radius for this problem. So this would be the diameter, right? This distance from here all the way to here, that's the diameter. So if that's the diameter, what's the radius then? Okay, so if you remember the relationship between the diameter and the radius, if I just take the diameter and I divide that by 2, then I get the radius. Okay, if I cut that in half, that would be the radius. So that would be 3.5. Okay. So multiply this by 3.5. Again, make sure the radius is squared, so 3.5 squared. And then we'll multiply that by the height. And even though the height is inside the cylinder this time, it's still the height of the cylinder. I could take this height and scoot it over, and in this height here would be the same length as this 9.9 that's in the middle. So same thing, so we can just multiply this by 9.9. Okay, so then I get 3.14 times 3.5 squared, and I multiply that by 9.9. And we are left with 3,000, oh, not 3,000, oops, 380.8, and this time it's in centimeters, so 380.8 centimeters cubed. Awesome.